Well, welcome to the second episode of the Power Defender. Today, we're deep diving into the realm of artificial intelligence and cybersecurity. I'm your host, Thomas Gentry, and I'm thrilled today to talk with our CEO, Dan Wanchler, and the CEO of Polyverse Corporation, Alexander. Gentlemen, I'll pass it over to you real quick. Thanks for joining us. How you guys doing today?
Doing great, Thomas. Thanks for doing this again. And Alex, my very good friend and fellow Seattleite, appreciate you taking some time today.
My pleasure. Glad to be here.
Absolutely. Again, thanks for joining us. Our key focus today is going to be understanding the unique impact of different types of AI in cybersecurity. Specifically, we'll be discussing machine learning and knowledge-driven AI. Before we get into that, though, I want to pass it over to Alex for a brief introduction. As I mentioned, he is the CEO of Polyverse Corporation and was a former CTO at AOL. But Alex, I'll pass it to you.
Thanks, Thomas. Well, greetings, everybody. It's a real pleasure to be here. As Thomas said, I'm Alex Ganaris, I'm CEO of Polyverse Corporation. We make AI productivity tools for software developers. And in particular, we help software engineers use the power of AI to maintain and upgrade and modernize legacy applications. So if you have any ancient code bases in COBOL or .NET or PHP or what have you, we can help you with that. And prior to doing this, I was a CTO at AOL. I was also CTO for Microsoft Online, and kind of my claim to fame is having been Bill Gates' technical advisor for many years. I've been doing AI and cybersecurity pretty much my whole career in one form or another. So looking forward to the conversation today.
Perfect, Alex.
Yeah, one thing I'll add, when I was with another firm called Route 9B, I saw Alex's Polyverse at the time was focused on moving target defense and cybersecurity. This is 5+ years ago. So I called and flew out to meet him because I literally thought it was going to be a silver bullet and kill every cyber project I was working on. So while it is great, we are still here. And Alex, I'm glad to call you a friend now after all that time. And one last thing, Alex has the skill set on not only knowledge-driven AI and machine learning that Thomas mentioned, but a big focus today will also be large language models and then generative AI, which is a big part of what Polyverse is delivering now to the customer base.
Great. Thanks,
and I appreciate that. Alex, thank you for the background. Again, thanks for joining us. No joke, that's a pretty cool line to be able to drop, being an advisor to Bill Gates at one point in time. So very cool.
It was a fun job. Got to work on a lot of different things.
Absolutely. I could only imagine. All right. Well, before we hop into it, let's take a quick look at our agenda. What we're really going to get into today is kind of understanding the unique impact of different types of AI and cybersecurity. We'll get into some real world examples, case studies, success stories, and then answering how do different types of AI bring value to cyber.
And I think I'm kicking this off, and Alex, looking forward, as we talked about, it's going to be just a little bit of a conversation with you and I, and Thomas jumping in as needed. But as our company's coming to market, and we've met with 120 plus MSPs, MSSPs, and other folks that might be interested in what the Darklight solution is. And Darklight has an underlying knowledge-driven AI. And we've chosen, and I'm just interested in your take on this, Alex, we've really chosen not to put the AI component first, because there is so much sort of, as some of these prospects will tell us, snake oil out there, and is it really AI, and what does AI mean? And so that's really the purpose of this conversation. And most of the time what I hear from just maybe people that weren't Bill Gates' technical advisor, they'll lump AI all together in one thing. So they're not really breaking it up. But even though our focus today is 3 types, machine learning, generative AI, most people think of that as the chat GPT, otherwise known as large language models. And then the SIO, our product is called SIO with Darklight, knowledge-driven AI. And there's others that people think about, natural language processing, robotics, and a whole bunch of other things. But these are the 3 we're going to focus on. So Alex, would you just give a little start on what machine learning is as that subset of AI and how that is generally could be or is applied in cybersecurity from your experience?
Sure. Yeah. So first, it's a little tricky these days to put clear labels on everything going on in AI, because it's the historical labels have been vastly abused and sort of overly stretched in their definitions, and frankly, the field is changing so fast. But having said that, it's probably easiest to break the world into three big camps of AI. You have your traditional machine learning, which, again, at the risk of vastly oversimplifying, you can think of that as really sophisticated pattern matchers. A great case in point would be like fraud detection on credit card transactions, right? If there's, you can train up a model and say, here's a pattern of somebody, going to the gas station, going to the grocery store and all that. And they live out here in Seattle, and all of a sudden there's a transaction in Florida. Okay, well, that doesn't look like the rest. So maybe that's an issue. And that sort of pattern recognition, traditional ML has been great at. But it was traditionally limited in that you couldn't really do much beyond what you trained it for, the patterns that you sort of trained it to look for. Then you had your traditional knowledge-based systems, your expert systems, things like that, where it wasn't so much a statistical system typically, but more of a rules type approach, where you'd say, well, if A happens, then B should follow. If you drop a rock, then it will fall. And people, they get fancy and put in some statistical modeling into expert systems and so forth. But at the core, you can kind of think of them as being driven by some sense of truth, if you will, some rules about the world. And those, again, worked really well for their domains where you had the time and expertise to go program them up. And then, of course, generative AI came out with sort of this thesis of, well, what happens if we train up a model with every bit of written word we can possibly find? And one of the remarkable things that came out is these generative models, sort of simply said, became smart, right? Or at least have the illusion of smartness. And if you sort of take a step back and think about it, it's both remarkable, but it kind of makes sense, because everything that we know as humans, with some exceptions, is something that's been written down, right? Think about all your school years, whether it was high school or college or whatnot. You got a book, you read the book, you learned something, and so to basically think of language as the representation and repository of knowledge was actually kind of a very fundamental insight into generative AI, and that opened up the whole ChatGPT experience that we all have come to know. And there's some limits to what you can express in language. Like anybody that's been in love before might say, yeah, that's something that doesn't really translate well to the written word, and people have been trying for tens of thousands of years to represent love in the written word. And yeah, still, you can't read about it, you just got to do it, right? So there's some limits to what language can represent, but as a general theme, it's been undeniably a huge breakthrough, and it's been transforming everything. Now, the real interesting magic happens when you start combining these, but that's maybe the topic for the next question there.
Well, and Alex, thank you for that. I think one of the things that even when you talk about, when we started at the machine learning part where the training is coming into play, and you gave a great example on, what training might be related to fraud. And then in the cybersecurity space, I think of the user behavior analytics or something along those lines, where I use my computer 98% of the time, or even 100% of the time, between whatever 5 a.m. and 7 p.m. And so if there's a monitoring going on and all of a sudden my computer's on and being used at 2 a.m., in theory, that would be an example of machine learning, correct?
Yep.
So under that scenario, when you look at where machine learning can be helpful versus, let's just go to generative AI, would a generative AI have a capability of understanding or dealing with that behavior pattern, or is it best to still keep these separate AIs doing where their strengths are?
A bit of both. You want to use them where their strengths are. So let me give two examples. I'm going to start with one that might well, hopefully scare folks a little bit. So let's take this from the attacker side. Where are people using the latest AI technologies to cause harm? There's a whole discussion we should have about fake videos and fake audio and so forth. Let me park that. Let me now talk about the very specific sort of the old-fashioned virus and sort of software takeovers of systems. In the old days, like a year ago, which is kind of crazy to think of, but
pre-December 1st of 2022.
Or November 23rd, whatever it was. Pre-ChatGPT in the good old days. We know when the Terminator's coming back. Is last November. Anyway, in the good old days, you would use, as the attacker, if you wanted to do something like what's technically known as a blind rob, one of these memory takeovers of a machine, you would use various forms of machine learning techniques to go poke at a system, go find a website, something up there. You'd poke at it, find a crash, use that crash, do some basic pattern matching, and then iterate to craft your sequence of return-oriented programming attacks, the so-called blind rob attacks. But you would just poke at it. I don't want to say you did it blindly because it was somewhat guided, but it was largely a blind process. These days with generative AI, you can have ChatGPT or any of the open source systems like Llama or Falcon or any of these things. You can have them go and analyze source code. And turns out the generative AI is incredibly good at finding bugs in your code. Now, if you're the attacker, that's brilliant news, because all you're doing these days is now taking your victim system, whatever it is, and now you're running the generative AI over it to go find bugs. And don't think being proprietary like Windows helps you, because you just simply, and I've done this myself, it's kind of cool. You take the binary code of Windows, you translate it into assembly, and then you run the AI over the assembly to go find the bugs. It works just as well. The AI tools will happily find bugs in assembly code. And so now as the attacker, you're combining both techniques, because what you can do is use the generative AI, find a set of bugs. And once you have a set of bugs, now it's like scoping out I've never robbed any place, but I've read about it. But what you see in the movies where the bad guys will, was it the Ocean's 11 movie, right? You scope out the casino you're trying to rob, right? And you find out that, oh, hey, they leave the back door open, right? So you're scoping out the place you're trying to rob. You find out that the back door is open. It's a lot easier to rob the place if you know the back door is open. And so when you use generative AI to find the vulnerabilities, you can now give your more traditional machine learning poking algorithms a better place to start looking. You say, go to the back door, right? Go try to break in there because that's where the vulnerability is. And so the combination of the two is scary, and I think we'll easily see a rise in cyber attacks, and in particular, we're going to see a rise in these so-called blind drop attacks and so forth, where traditional tools can't find or detect these attacks.
Well, it is what's scary. Certainly, you and I have even had conversations about the power of generative AI in general, and how it actually, in some of the new cool tools coming out in cybersecurity, using generative AI and really using the specific large language models, which I want to ask you about in a minute, as compared to just like ChatGPT, to help defend or respond more quickly in a SOC, and lots of things that takes human time away from humans so they can focus on perhaps the more sophisticated issues. So the generative AI is being very powerful from the attacker perspective. But back to that specific example of I'm on the computer at 2 a.m., will a generative AI be helpful in a defender capacity in that scenario versus machine learning, and even to some degree knowledge driven, especially when you compare the three for resources that it could take to deploy the tool or the AI?
Short answer is it's going to be super, super helpful, but only in combination.
Got it.
So the let's take the case now of the defender side, and let's use somebody's logging in, at an unusual time. So I'm going to say the traditional sort of, whether it's a knowledge-based approach or trained ML approach, they're going to pretty easily notice, hey, this is unusual activity. But if you've ever been traveling and get stuck somewhere, like because you missed a flight and you got to go buy something on your credit card and it gets denied, that is like the most freaking annoying thing in the universe. Like right when you need your credit card the most, you're screwed, right? Because some overly trained ML system somewhere said, oh no, you live in Seattle, you don't live in New York, so we're not going to help you out when you're stranded in New York. And it's like, that can be super, super annoying and frustrating. And that's the limits of it sort of reveals the limits of the traditional ML systems. And the reason that's limiting is because the ML system doesn't have any additional context. Now, it's pretty easy to imagine, though, a future system where, think of generative AI it's almost a bad name because it's something that, you think, oh, it's only producing, but it can also do on the understanding side. And I think in 2024, one of the big things we're going to see is a lot more what's called agent-like functionality, where these large language models and generative AIs are doing things on your behalf. So you can easily imagine a future, security system that where I had my personal agent using generative AI, and it knew that I was traveling to New York, and because it read my emails, it saw my invoice from Alaska Airlines or what have you. Although maybe I shouldn't fly Alaska Airlines, at least not the 737 these days. But the generative AI can basically do that understanding of what's my context. Am I really in New York or not, right? And did I really fly there? And do I need to get the have my credit card unlocked? And so if you combined those two systems, where the traditional system would say, hey, this is an unusual credit card transaction, or this is an unusual login, but I know Alex is legit, right? Because he really did travel here, or he really was up at 2 a.m. because he's, in a different time zone, or what have you. That's when we're going to see some real power on the defender side. because we're going to eliminate, or I should say not eliminate, but greatly reduce a lot of the false positives.
Well, so that's a great example, because it's providing additional context.
Exactly.
That, the way I understand it, in the machine learning environment, one of the biggest limitations, and also the greatest power, are the training models. And there's, I don't want to go off subject here, but that's also one of the weaknesses, because as they're training, you can, in theory, have an adversary help train the wrong thing, but that's a separate story. But the combination of these AIs is where I think you would agree, and we certainly do, that's where the magic's going to really happen, to use the different strengths of them, because the generative can handle so much and even proactively add context without quite the same constraints as the machine learning. But there is this idea of training for either, I believe. And can you give us a little bit more about what a large language model or narrow model, or when you think about generative AI, when you look at some of the firms that are coming out, like Dropzone AI, which I think is going to be really cool, using large language models specific for automating SOC work, they're not just going to Chat GPT overall. They're using the large language model specific to XYZ. What does that really mean for those that might not understand that?
Yeah. So let me first start with sort of a base mentality, if you will. Sort of think of these large language models as just sort of a fundamental capability of understanding language, right? I'm old enough now, when I first started programming, doing something like communicating over there wasn't an internet really. We had ARPANET, but we had the military version of it, but there wasn't a big public internet. So doing something like communicating from one computer to another was a big deal, right? Or communicating to a printer was a big deal. And you had to write a lot of code to go do all that, right? It wasn't super easy necessarily. And these days, you sort of think, oh, it's just a website, right? It's no big deal to go build a system that runs across many different computers. Just like a year ago, it was a big deal to have a system that understood language, right? What is New York City? What is travel? What is an airline ticket? What is a login? What do these words mean? And so we now have sort of that fundamental sort of capability that can be built and incorporated into your systems. And so where I think a lot of the innovation is going to happen is saying, all right, let's assume that ability to converse and understand in natural language. Now, where do we add in the specific context, the specific extra domain knowledge, whether it's, how do you automate a SOC, or like in my company's case, how do you deal with legacy software, and so forth. And the easy analogy I would give, and folks can try this out on their own right now. Imagine going to, or just go to Chat GPT and ask it to plan a dinner party. And just nothing else than that. Just say, please plan me a dinner party. Actually, ChatGPT does a pretty good job, right? It'll come up with something, but it will imagine something. It'll maybe say, okay, well, we're going to do steaks and hamburgers, and so it'll give you all the instructions for getting the steaks and recipe for hamburger and everything else. And that can be fine and good unless your guests are vegetarian, right? And so, it's kind of luck of the draw with a base system. If you don't give it any extra knowledge about what it's supposed to go solve, it'll happily generate. The math of generative AI and math of large language models says it will always give you an answer. Whether that answer is right or wrong, it doesn't care. It will always give you an answer. Mathematically, it will come up with something. And the way you get to good answers is by providing the right context and the right sort of framework of, here's what we're really trying to do. Oh, I have vegetarian guests. And so let's plan a dinner party that's appropriate for vegetarians.
That's really, really helpful. And Alex, we've got a number of questions that have popped up, and I think where I was going next will answer probably a few of them. And then Thomas, if you would just kind of keep track to make sure that because there's a lot of good ones, and Alex, you might want to scan the comment section for those as well. It's in the upper right. And so part of what we've talked about before, Alex, and this idea of where does each fit? And one of the specific questions here was natural language processing. And from my perspective, with our company focused on knowledge driven, and even the underlying tech that was built at a national lab, the problem set our underlying tech was solving was an NSA scale data problem where you had very different types of data and sources of information coming into one, call it a platform, that had to provide an analytical solution because the data size, the information size was so massive. And so you could have specific signals intelligence data coming in that maybe, somebody's phone number or what have you, that information coming in. And then you could also have a handwritten, or a report written that's maybe in PDF. And so by scanning the PDF, this is going to come to a question for you on NLP versus generative AI, the natural language processing, we were able to take, sort of handwritten reports or written documents and turn them into knowledge within the AI, very specific. And in Darklight's case, it was specific to APT3, Chinese adversary, known by name. That's their name in the greater public library system. And that adversary has however many campaigns. So whatever, there was 6, there could be 10 now. I'm not really sure. But campaign 5 has a very specific playbook that they use all the time. Because just like you were sharing, once an adversary has a bit of a path, based on an X backdoor potentially being open based on some tech stack, they just start throwing that playbook at lots of different potential victims. And so where knowledge-driven AI comes in is it's very efficient it's not quite as simple as antivirus, but to me, it's pretty similar. And if you think I'm wrong with that, please let me know. But it's really just taking that knowledge that's now in the system and looking for that playbook and getting that kind of data in becomes very easy with natural language processing. And to me, it also with generative AI, because it really, you're being able to understand what these words mean. So this technique is to go to a PowerShell and do XYZ. What does all that actually mean? And how can the computer machine read it and then act on it? And that's kind of how I would think about how the three of these really work together.
Exactly.
So did that make sense? And then anything else you want to add about NLP? Because that was a very specific question here. And one I'll add on to it. Does the generative AI functionality start to reduce, or is it just another version of NLP? Because I can right now upload into ChatGPT a PDF and and use it to derive lots of other things. So how, and I've never thought about that question. So how would you answer that with NLP and generative AI, and are those mushing together?
They're mushing together is the simple answer.
It's a very technical term, mushing together.
Look at sort of the 10,000 foot level. Anything I could do with NLP, I could do with a generative AI, or maybe more precisely said, a good large language model. And where I think we're going to see, which we're seeing this now, and I think we're going to see more of it going forward, is we call it a specialization of techniques. So going back to this overall theme we've been talking about of bringing in the different types of, rule-based systems and knowledge systems and ML and LLM systems, and sort of taking the best of each of them. I'll give a very real world example from my own company. Like many people, we started building our new product using GPT, Chat GPT 4.0 is our underlying base, and it worked brilliantly. We got all kinds of amazing results, except that the costs were enormous. To really do a deep security analysis of our customers' projects would require about 5 days straight and about $15,000 of just the AI cranking nonstop. Now it worked, and it was just amazing what you could find, and we'd find these bugs that even me as an expert, I had to look 3 or 4 times at it and say, holy shit, that's a real bad bug. One of them was in a voting system, but that's a whole other discussion. So the AI can find these things really well, but it's expensive. And with our new release we'll have coming out later this month, we've gone from 5 days to 15 minutes.
Wow.
And the way we did that was by being smarter about which AI technique we would apply when. And the casual example I would give is, kind of the naive first approach you might use to any AI problem these days is say, well, let me just use ChatGPT. Well, that's kind of like going up to Gordon Ramsay and saying, Gordon, I need you to make me supper, but you've got to do everything, right? You've got to prep, you got to go to the grocery store, get the onions, get the meat. You've got to chop the onions and do everything. And you know what? Gordon can do it. And it would be a very tasty meal. But if he charged you a fair rate, that would be a very expensive meal. And instead, why not have Gordon Ramsay still in the kitchen? But let's get some sous chefs in there too. Somebody else to go to the grocery store, get all the food, somebody else to chop the onions. You don't need Gordon Ramsay to chop an onion. And so I think we're going to see, even traditional NLP systems, still have a very important role, going forward where, these more specialized, AI techniques that can be run cheaper and faster for, pieces of the puzzle. So use them; they work. You don't need to.
Yeah, and a great example. Sorry, Alec. A great example brought to me is, when you think about, and I'll try to also spin into one of these other questions, and maybe even two with the one that's on here now about transparency and accountability. When you think about transparency and accountability, the strongest one, I think you'd agree, is knowledge driven, because even as you described it before, it's based on truth. And so where we're sort of setting up is that you can have the knowledge driven both before and after either versions of your AIs. And so the machine learning, which can be really good at identifying things that aren't known yet because of pattern recognitions that maybe haven't been seen yet. So APT3, let's say they have 7 campaigns that are known to the community, and now they've started their 8th. And machine learning can figure out, wait, this pattern looks really close, but I've got to make an alert here, even though it's not the same thing. And then you can apply knowledge driven to compare it. And then as the industry understands, yep, APT3 now has a campaign 8, you then either have to you would either have to train your machine learning models or pop that into knowledge driven. And if you're adding all of that to generative, it can be very expensive. And so if you filter out a lot of that before the generative comes in to get all of your known good and known bad sort of handled, exactly, and then deal with generative, you can save a lot of money. And frankly, ours is even used to put sort of, and we're big fans of Splunk, but you can put it in front of Splunk to reduce your costs. So you're getting rid of stuff for the cheap AI, call it. We think we're very valuable, but you know what I mean, on resource allocation. And then really take this amazing power of generative but you don't need Gordon Ramsay to cut up your onions. I'm even capable of cutting up onions.
Yep.
So, and then
And that's
some
a
of the things
great,
here
great
that
use
I'm
of
really not.
what you all are doing.
Okay. Thank you. The one piece, though, that gets a little over my head is when you talk about another question here. And sorry, I hope I answered the one question that was up about ethics and transparency. And so this is where I do believe the industry and other industries will and should be using a combination, because knowledge driven, the power of that is it really is controlled by humans. And it is what is known and then what's also good about it, it is completely reproducible. And so if you put one set of facts through, on the other side, you will always get the same result, where that is not always the case with machine learning because it's always changing. And it may not even be the case with generative because it's constantly learning and adding more to it, whereas the knowledge driven is 100% explainable and fully reproducible. So there's some transparency and ethics around that you can even put that on as a kind of a guide rails for the other usage, because generative still has some hallucinations, but the generative, in my opinion, is the most powerful, but it's the combination where the magic's going to happen.
Exactly.
Now, what about this machine learning versus
hallucinations? That's mathematically required.
Mm-hmm.
There you go. It makes sense because, I mean, maybe it's giving it too much credit, but it's also its version of imagination, and that's a little weird to say, but I mean, that's
exactly
helpful.
What it is. If you don't mind a quick 30-second detour, I think folks might find this interesting.
Yeah, please go for it.
So, as I mentioned, I've been doing AI a long time, and worked on Microsoft's original spell checkers and grammar checkers. Those were some of the very first AI systems that we came out with. And you sort of think about the history of AI. Again, I'll oversimplify and say, for the longest time, we sort of had this theory of there's a right answer. Right? There's a correct way to spell something. There's a correct grammar. There's this credit card transaction was fraudulent or not, but there was a right answer that we were trying to get to. And kind of all of our work in AI and ML was to try to teach a system to get to the quote right answer. And then I believe it was 2017, might have been 2018. The Google researchers with the "Attention is All You Need" paper. Absolutely fabulous paper, worth a read for anybody that likes math. It had a number of breakthroughs in it, but the simplest of which was it said, you know what? What if we allowed the AI to lie? What if we basically said, you know what? It doesn't have to get to the right answer. What if you let it guess a little bit and come up with something that's wrong? And that ended up being a huge breakthrough because you think about now trying to analyze and understand like all of the text, all the written language out there. The practical reality is, for a lot of things, there isn't a right answer. Is President Biden a good president or a bad president? Oh boy, right. If you were to analyze every tweet and every newspaper article written, how in the world are you supposed to come to some judgment of what the right answer is, right? There's a lot of different opinions and perspectives on that. And a lot of things in the world are like that, where there really isn't a, truth with a capital T. It's really a question of perspective. And so when they relaxed the math of the AI algorithms in this "Attention is All You Need" paper, it gave the AI the ability to start reasoning through contradictory stuff, because you basically said, you know what, it's okay to be wrong, it's okay to lie, it's okay to hallucinate. And that was just sort of a very fundamental breakthrough. But it means that generative AI, without augmenting it with additional context like a knowledge system or like what GPT does with their code interpreter, unless you augment it with some source of truth, it will always hallucinate.
Mm-hmm. I'm going to show. Yeah, go ahead. No, it's a great point. I've not read that. I'm not much of a math guy, so that could be tough for me. But I'll take it.
It's a very good paper.
there's one other that I wanted to sort of bring up here, and this wasn't part of the plan, but I appreciate the question because, one of the things I believe, and actually, Alex, I don't think you and I have talked about this, but I'd love to get your opinion, even if it is different. So that's what's great about this. What I worry about in cybersecurity is everybody's looking for that silver bullet tool or that monitoring or that endpoint or something that just solves their problem. And this is, I think, a great question that I'm not judging people's question, but this I think is a great question on how do we look at this stuff. And one of the things that at least we found, I'm not saying this attendee feels this way, but we went back and started, because some of the things we were doing early with ours where we were automating threat hunting, and we literally would bring all of attack into our knowledge base. So we would have ontologies, fancy word for the new if-then statements, just less brittle, so the computer can truly understand everything that is known about APT3 and its tactics, and procedures. And so we started way in the sophisticated level, kind of high into the right of sophistication. And now our product comes to market with, let's focus on the fundamentals, call it left of boom versus right of boom response monitoring, left of boom preventative. And when you get into these predictive analytics and things like that, one of the things that we believe that many and most tools miss out on is, even getting back to your comment, Alex, what's the context? And so if you don't have some basic understanding of what's in your environment, which we know asset inventory is a big deal, a lot of good tools trying to find that and see what shadow IT is and those sorts of things, but trying to get an understanding of what's in your environment. And then the one I think is missed a lot is, who would want to attack you and why? And it may or may not be a specific adversary, like I'm, Lockheed Martin, and I know China wants to get my secrets. That's pretty black and white. Yeah. But if you're an e-commerce site or someone that has access to credit cards or something, you're looking at sort of the common thief or the organized crime versus nation state, and you can start to narrow in on what should you care about first to start doing things and taking advantage of predictive, because you can never be 100%. So when you think in terms of risk, which we talked about in the last program here, risk is likelihood times impact. And so you try to narrow in on what are the likelihood, meaning this is a bad guy or a type of bad guy that would like to attack me. Here's why. And here are the systems that type of attack would be most impactful. And here's how that would impact my business. And all of those things should be known. Yeah. And if you can automate a tremendous amount of the known, instead of trying to find the silver bullet of how do I just deal for all of it, which is impossible, let's focus. And I think people can really sort of dumb down in a good way their tech stack, their number of tools, et cetera, by just getting into the fundamentals. So with that in background, if you agree or disagree, let me know. But also sort of more specifically to this person's questions on, forecasting potential cyber threats, because to me, you do that by understanding vulnerabilities, understanding inventory, understanding the impact, and then theoretically taking the time to understand who would want to attack you and why.
Yeah. I think that's spot on. I largely agree, but I think the challenge is probably going to be even greater than what you described. And so maybe the way to look at this, and this kind of gets to Mr. Stan's question here, at the end of the day, whether it's a nation state or organized crime or just somebody out to cause grief, there's a human driving these attacks for some human motivation, right? It's their job, or they want to make money, or get fame, or whatever. And so, if they find something that works, they're going to do it again, right? Just like if you find a dish you like at a restaurant, you're going to order that again at some point, right? I mean, we're all human at the end of the day, and the thing that I think is changing and maybe making it worse is you use some phrases, Dan, like saying, where we had more of a high-end system, we're really more focused on against the APT type threat actors and attack patterns and so forth. The problem is that is now going to become so easy to share on the bad guy side that kind of everybody needs to defend against even sophisticated attacks, right? Because it's just we need to be in this mental model of however hard you thought it was to launch an attack before and carry out more sophisticated live off the land type attack and go penetrate systems. However hard you think that is last year, it's going to be easier this year, and it's going to be easier in 2025. Right?
Really good point.
Because the systems are the bad guy systems, if you will, are getting just as automated, right? Mm-hmm. And you can have the AI go drive a bunch of stuff and run a bunch of the experiments and go do the probes, and you can have even the social engineering side of it. That's something I hinted at before. The social engineering side, which used to be I don't want to call it, it's not a gate, but it used to kind of slow things down because that took time and effort, right? If you wanted to go phone somebody up, that was expensive. Mm-hmm. Well, now you can have an AI phone somebody up and it sounds like me. It sounds like you, right? You can do a video chat and it's going to look like me. And so, every sort of, the entire attack chain, if you will, is getting automated, including the social engineering aspects of it, and including some of that reconnaissance aspects of, did they leave the back door open or not? And so the attacks are just going to get more sophisticated and more broad because it's like the Target hack. They didn't get into Target through the front door; they got in through the HVAC vendor. Mm-hmm. Right. So if you want to go hack Lockheed does a pretty good job. But do every one of their vendors do a good job? Right. You go in, you find the back door that's left unlocked, and now you can do that at scale. Right. And you can have AI robocall. Every junior employee at every vendor and try to trick them into giving up their passwords or saying, oh, you got to, I'm from help desk, you've got a problem with your computer, let me do the remote control assistance to fix your problem.
Alex, and you're making a really good point. I know Thomas has one more question as we're going to start wrapping up here, but I want to ask one in the context you're speaking of. And combining some of the words, some of my thoughts there, when you look at this question that Mr. Stan wrote out, if you can no longer feel safe on not having to work to a nation state style of attack because those are so easy to get access to and or what have you, because look at what's in the wild when you look at Stuxnet.
Yeah.
I mean, that was amazing. And those techniques, procedures are in the wild. So your 16-year-old kid in the garage can now use those. So it makes you've made a really good point there. But now go back to, well, what is the small company? My wife has an interior design firm with 15 people, and she serves, perhaps a high net worth client that people might want access to. She can't afford some of this stuff. So just this idea of reducing and trying to predict where or how they might come, do you believe in still the fundamentals on the understanding risk, understanding, what things matter the most, and then putting up your defenses as best around that? Or what would you do in a small business environment, given the reality of how these attacks can be so much more sophisticated for less cost?
Yeah, so I think there's let's come at this from three different dimensions. If you're a small business, you've got to use the best, tools and capabilities available to you that you can afford, and to some degree do the best you can, but you won't have a DoD or NSA level cyber posture. You can't afford it, right? It's just not gonna happen. And so that does put the burden now back onto two other players. First, as an industry, the more that we can do to get effective tools broadly deployed, the better, right? So if everybody was using Darklight, we would not to kiss ass to my host here, but you all have built a phenomenal system to understand these patterns in a very repeatable and predictable way. All right. Well, that needs to be, everybody needs to know that, right? Because if you don't, it's kind of knowledge that's there for you. Just go take it and use it and be smarter for it, right? And so the more that as a cybersecurity industry, we can get our tools broadly deployed, the better off we're going to be. Then there are legislative changes that could be made on the government side that would greatly help things. And this one can be a little controversial here, but one of the, I want to say, expose a little bit of dirty laundry or dirty secrets of our industry. How many successful cyber attacks in the last, say, 5 years or even 10 years could have been prevented because if the commonly available technology was deployed? And if you want just a very, very real world example, how many successful cyber attacks are there in the iPhone ecosystem? It's not zero. People
Right.
can hack these things. How many successful cyber attacks are there in the Windows ecosystem? Right.
Are you and Bill still friends, Alex?
Yeah, we're still friends. But it is unambiguously the case where Windows is suffering from much weaker cybersecurity posture. It is also the case that a lot of the attacks that are successful could be solved if Microsoft were to make the investments there. Because whether or not, there's a whole other discussion, and I wrote it up in my blog. Do they need to go license stuff from Apple, or a lot of different things they could do, but the technology exists. And so now does Microsoft have the business incentive and willpower to do it? If there was a legislative change where software companies became liable for preventable software defects, now what happens?
Yeah, that'd be a big change.
It'd be a huge change, right? You can't make a car these days with knowingly defective brakes.
And I am not a fan of legislation. Being an entrepreneur, I know you are as well, with the idea of just overburdening some through legislation. But because of the things we've talked about today, and Thomas, I want to kick it back to you here, but I don't see how in the small business context or even medium-sized businesses that they really have a shot of this. It's just moving so fast and too complex and so far. I mean, it's even hard. I don't know how you do what you do. You have built a solid company. You still code, and yet you still are on top of all of those things. It's very rare that exists out there in the small business environment. So anyway, Thomas, I know we've only got 5 minutes, but you had, I think, one more question you want to bring up. And for
I actually do. And Dan, I appreciate that. Alexander, first off, thanks so much for today. This has been an engaging conversation, and it's been exciting to listen in and participate. one thing that I want to kind of pivot, I was going to talk about the human and machine kind of collaboration, the utilization of AI. I'd really like to kind of just talk more, though, about advice for the organizations, right? For our people that are out there listening today, looking to incorporate AI into their cybersecurity strategies, what advice would you offer to ensure an effective and successful adoption?
That's a great question. So I would maybe break it down into two categories. One, look at your own internal processes and ask the question, where can I employ AI technologies? And whether it's ChatGPT or Darklight or any of these things, where can I employ these technologies to improve my own productivity and efficiency? Because I guarantee if you're not, the bad guys are, and your competitors are.
That's right.
And we see this right now in incredibly dramatic ways in software engineering, where the generative AI tools are so good at writing software that the developers that have embraced it are seeing a 10x productivity increase. It's absolutely mind-blowing. And so if you're not, adopting these tools, you will increasingly become uncompetitive. And don't think you can catch up either, because the real challenge is not so much the tools, it's understanding the workflow and your internal sort of organization processes. It's the people that are the slow part of this, right? So it will take time to learn how to use the tools effectively, how to adapt your processes effectively, and so forth. But that'd be step one. Learn how to improve your own productivity with it.
Find your onions, if you will, right?
Was that?
Learn how to chop your own onions and leave the things.
Yeah. If you want to use that analogy still, yeah, absolutely. But or learn how to have the AI chop the onions for you. Because right now you're chopping it yourself and the AI can do it just fine.
Mm-hmm.
And learn where the AI isn't going to help, right? Then the second thing I would suggest, and this is particularly apropos for anybody in a security organization at a company, whatever you thought of as decent defense in 2023, you're wrong. Right? It's just a guarantee it will not be sufficient going forward, right? Right now, maybe if you're really paying attention, you can tell the difference between a faked AI-driven social media call and not. Within a few years, you're not going to tell the difference, right? The AIs are going to be good enough where, they're going to be able to fake out anybody, right? So don't rely on having the humans in your help desk to go reset passwords, because that's going to get faked like crazy, right? Same thing on your software systems. Don't rely on security through obscurity or anything like that, where, because the ability for an attacker to automatically find and discover bugs and exploit them, that's not being done by human hackers anymore. That's increasingly being done by an AI. So now these exploits are going to be coming at us, not at the rate of human hackers, but at the rate of an AI hacker. So we've just now begun to see the onslaught of this. And this is why it's so crucial for the industry to catch up to, at least an Apple level, and even Apple's got a bunch of stuff they need to do to sort of further improve.
Yep.
But as an industry, we've got to just take a step change in the quality of our software.
Perfect spot there, Alex. Go ahead, Thomas. I know we promised everyone to wrap up right at 1. It's top of the hour. So Thomas, please.
So to kind of to circle back on that, I think you're absolutely right, Alexander, and those are great places to adopt it. When you start thinking about AI being used in the attacking side, before we had things like brute force attack was really where we were looking at multiple instances of one thing. But if you expand on that with the AI model, absolutely, you really have to be able to defend that. So great. Thank you for your time today. Dan, thank you as always. Folks, our next webinar is on Valentine's Day. Feel free and bring your sweetheart if you like. We have some exciting news that we're going to be talking about. Again, if you're not following us, LinkedIn, X, Facebook, YouTube, Instagram, feel free and follow us. Gentlemen, it's been a privilege and an honor to talk with you. I look forward to having you back again in the future, Alex.
Great.
Thanks, Alex. Great to see you. Great questions from the audience today. So thanks for that, everybody. And till next time, take care.
Thanks for joining us, folks.
Great.
Have a great one. Bye-bye.